All right. Here we go again. Hello, world. Welcome, programmers. Welcome, music lovers. Welcome to Code and Coda. We are streaming live from Boston, Massachusetts. It is wonderful, excellent, lovely, great Sunday evening. Thank you for joining us again. See some good friends in the audience. My name is Joseph Parzell. I'm your host, of course. On guitar tonight, we have my very good friend Eric Gaudet. Well, let's get to it. Here we are in episode 3 of season 1 of Code and Coda. Here you can see our season 1 abstract, and if you have been with us for the first 2 episodes, you may see something a little bit different with the season 1 abstract here. We have added an episode. Last week's episode ran a little bit long, so what we're going to do today is a quick recap of last week, and then we'll go ahead and finish off the slides from our request episode. And so, no big deal, we are an agile development team here in Code and Coda. So we just had to change the schedule a little bit, add another episode, and we'll go ahead and take care of the rest of our request slides. The technical specification for episode 3. Basically, it's the same as last week, so I'm just going to go ahead and click through these first few slides a little bit quicker this week than last. I'd like to finish this episode in 30 to 45 minutes, so that puts the end time of the episode at 10:15, of course, with a nice coda from our friend Eric. So let's go ahead and get right to it. Why Code and Coda? If you've been here with us past couple weeks, you know that this was my presentation for Teams Thursday, so I virtualized it since Teams Thursday was canceled and asked my good friend Eric if he would perform music while I ran through the slides. So if you'd like to go back and review any of these slides at any time, you can just hop onto YouTube, look for Code and Coda, and you will see each episode after every week will be online and available. So, quick recap from last week's episode. Of course, as I mentioned, it was a little bit too long. We only got about halfway through, and it was about an hour long. So, what we're going to do is I'm going to go ahead and try something new here. And before I continue, I guess I should introduce our special guest for Code and Coda. We have Alexa here. How are you doing? I should turn her on first. Alexa, how are you doing tonight?
Did you ever try to write a poem and it turns out bad, but somehow that's good? That's how I'm feeling.
Actually, I have. All right, thank you, Alexa. So, what I'd like to do for this week, for our recap, I'm going to run as fast as I can through the slides from last week. It is a lot of slides, but I am going to put myself on a time limit. So with Alexa's help, why don't I give myself a 5-minute time limit, and let's see if we can run through last week's slides in less than 5 minutes. Alexa, set timer, 5 minutes.
5 minutes, starting now.
All right, here we go. Well, first, we looked at my workflow diagram here, which takes you from the user to Alexa to the cloud and shows you kind of a nice overview of how the workflow goes from the user to Alexa and your web application. We discussed the meaning of the word parse, and after we talked about that word parse, we went to our Alexa developer console. We clicked on our Alexa skill, which takes us to the dashboard for that skill. After that, we clicked on the test tab, and we tried and see what it looked like when we typed in Code and Coda. We got our hello world, which was back from episode 1. So far so good. What we wanted to do was take a look at that request that Alexa sends to your web application. So we copied the request JSON data to Visual Studio and placed it into a JSON file so that we could take a closer look at it and still have some nice markup, which includes that color. You could see that our request also comes with a response, and so this is the response that is what you see on the testing console. Back to the developer console, you can see that we also looked at intents and the default intents that were there. If you would like to read up on those default intents, Amazon documentation is very good. What we tried to do was initiate one of those intents by saying the utterance help, but since our skill was not, since our skills flag, our response flag of should end session, which is default to true, was not set to false, what we did was set that flag to false, republish our web application, come and try this test again. We do our invocation name, which is Code and Coda. We get our hello world, and when we say the word help, we now get our intent fired, which in this case just returns the same text. So what we want to look at is we can see that in our request payload, we get a request type of intent request, and that's good because now we can decipher the difference between a launch request and an intent request. And with that code next to each other, you can see the different details that come along. These are two different requests here that you can see. So the next thing we tried to do was in Visual Studio create or update our web application so that we could decipher between a get and a post request. We also started looking into JSON, and if you would like to read more about JSON in .NET Core 3, here's an example of a website. So we come to our home controller default back code behind file, and what we did was we duplicated the index signature, but we also went ahead and, since we got an error, added something. We added a parameter, and we also added attributes, the HTTP get and the HTTP post attributes. After we added the parameter, we basically called that object type Alexa post request, and using IntelliSense had Visual Studio create a class for us. We moved that class to the models folder and renamed the namespace. One thing I missed last week was that in our code we are using the object called viewData, and that is one way that we are able to pass data from the code behind to the UI layer. So if you see here, this is one important piece that I skipped last week. The viewData object in our code for both the get and the post request is being set, and that get or post field of the view data object is set to either get or post, both uppercase. And remember that because in the next slide, when we come to the UI layer, what we try to do is erase all that junk out of there, and we say, okay, if it's a get or a post, we will behave one way or another. So we added some CSHTML to the page. We got a build error and realized that we needed to add some text tags around everything to make it look, or not look nicer, but behave correctly. However, though, when we ran the project, we were still getting the code. We were not getting the behavior we wanted. We were hoping to get the get page, and I realized that our string, of course, is case sensitive, but for some reason the view data fields are not case sensitive. Keep that in mind. When we build one more time, we do get the get page. The next step we tried to do is we started to create an environment that allows us to debug the skill. And the reason why we want to create this type of environment is so that we do not need to use an Alexa device to test our skill, nor do we need to use the testing console to test our skill. And that's perfect timing because Alexa, stop timer. That is the end of the recap. And what we will do next is take another closer look at this slide so we can just go over the workflow one more time, and I can continue on into creating our testing and debugging environment. So before we do that, let's check in on Eric for a minute. Thank you, Eric. Sounds great as always. I think now would probably be a good time for a sip of coffee. Cheers to my fellow coffee drinkers. So we are streaming, broadcasting live on YouTube. If you are in the YouTube chat and you have a question, a comment, or a suggestion about tonight's episode, go ahead and send a chat. I'll be checking on YouTube comments tonight through the broadcast, and we'll try to respond if I can. Okay, here's our workflow I introduced last week. And just to go through it again real quick, we say our wake word, which for this skill is Alexa. We say the wake word Alexa, and for this skill, our invocation name is Code and Coda. That wakes Alexa up. Alexa retrieves some data from her list of skills and then sends a JSON request payload to the cloud, which is hosting your web application. So Azure sends that JSON data to your web application as a post request. There is a difference between a get and a post request. So posting that to our web application, we will then parse that JSON data, and that's kind of the next step we're working on here. But what I'm working on and what we're going to look at together is basically I'm going to cut out Alexa from this picture so that we can test without having an Alexa device or even having an Alexa simulator. And what that means is we will have a get page and a post page in our web application, from the get page, we can send a post request to our own web application. So we're basically, for testing purposes, going to be starting at number 5, sending a post request back to number 4, which is the cloud, and then that basically sends the request to our web application again. I hope I didn't confuse you, but maybe we'll start looking at some code and that'll help out a little bit better. We did look at some of these slides last week. I'll try and get through them quickly, but remember, in our UI layer, we have a conditional statement here. So if we have a get, then we're going to do one thing. Otherwise, we are executing a post request. And if we do have a get request to our web application, we are going to start displaying things on the page and also running some JavaScript. So you can see here I'm referencing a few JavaScript files, and I put an input button on the page. Now, what I've done is jumped on over to our site.js file, which is the default JavaScript file that comes with an MVC web application, and basically nothing in it. What we're going to do is take out those comments, and we're going to start putting in our own JavaScript. And you can see the first thing I've added is a variable called post data, and this is actually the data that we're going to send to our web application during testing purposes. So again, we're cutting out the middleman. We're not sending data from the user to Alexa to the web application and then all the way back. We're basically just going to post data ourselves from our own web application. All right. So quickly we'll go through. You can see I've added my own function. This is just kind of my own style coding here. And I just like to use this little function here. And then one more function called post form, which is the function that will run when we click our button. So, whoops, went ahead a little bit there. Sorry about that. So, when we run our web application, you can see this is the get page of the web application. It's basically a simple button. When I click on that button, some AJAX runs in the JavaScript file, and that is done asynchronously. So our web application is sending a request to itself, a post request, and the response that our web application sends, you can see right here, is placed into the console, the debugger console. The way to open that, of course, is by pressing F12 in your browser. One more thing to keep in mind, the best part of performing your testing with this method, by basically creating a get page with some buttons that sends a post request to itself, is that you can now set breakpoints. So rather than using the Alexa device or the Alexa simulator to run your tests, you can just run them on your local host and set breakpoints. And what we will do is show you how those breakpoints are met and some more code. I do believe we went through some of these slides last week, so again, try to get through them quick and do some more chill learning. Hey Karen, good to see you again, Karen. How's Eric doing tonight? All right, let's continue through our debug method setup. And so again, remember, this is the get version of our web application, which includes a button that launches a post request to the same web application. You can see the response to that request is on the right-hand side in our debugger console. As I mentioned before, this gives us the ability to set breakpoints within our code. So now you could set a breakpoint, click on that button, and see that we are able to step through our code now. The first thing we're going to do is take a look and notice that our object, Alexa Post Request, is currently null. So the data that we're sending through the post request to our web application for some reason is not getting through. Well, one reason is because we didn't create these public objects yet. So what we're going to do is create two public objects. Those objects those objects represent the data that is contained within the JSON payload that is sent by Alexa. Now, if we hit our breakpoint again, Alexa Post Request is still not null. And I remember saying last week to keep in mind that in our AJAX call to post the data, remember you do not want to post an actual object variable. You're posting a string. So what you need to use is JSON stringify. You'll forget to do that a few times every now and then. Doesn't take long to remember after you forget a few times. And so once we stringify that JSON data and post that data to our web application, you can see now the object is no longer null, and we get two pieces of information here. We get a context object and a request object. Within those objects is information about the user, about the device, and about the request. Specifically the request type. And then if it's an intent request, we'll get in a request name. Let's keep going and see what that looks like. So as I was just mentioning, the next step here through the process, after you wake up your skill by saying the invocation name, you will say another word to try and activate an intent. And so in our code, we need to determine which intent was requested by that user and then respond appropriately. And take a look here, we have our JSON objects here. So what we do, create a variable to try and retrieve the data from that object. The type of variable is called JSON document. And we're going to call this variable JSON context. And the way that we retrieve the data from the Alexa Post Request object is by using the Parse method. Now you can see here this object JSON document is underlined, which means we would get a build error if we try to build this. Of course, what you can do is just click on the drop down light bulb and automatically insert the using statement, system.text.json. And now after you insert that using statement, you can see no more red squiggly. And we'll go ahead and do the same thing, create another JSON document variable for the request object. that comes. And you can see our Alexa post request object has some nice IntelliSense where we could just find those sub-objects. Once we get those two main objects from the Alexa post request object, then we can find properties within those objects. Before we try to parse through those properties of the object, it's always good to test whether or not your data is valid. One way to do that is to check and make sure that your variable that we're creating up here isn't null or some other type of variable. What we try to do is compare these objects, compare the value kind property of the root element property of these objects. And in this case, we're looking for the JSON value kind of object. So once you validate that you have the correct data type here, then you can continue processing your request. Otherwise, what you want to do is throw an exception. And in this case, if your JSON data is not correct, you will want to throw a JSON exception. Now, I would probably say that you will almost never get a request from Alexa that does not contain the correct data or correct data structure. So this block of code may never get executed, but of course this is just good programming. In case anything ever happens, you have a good way to trace what went wrong. The first property that we're going to look at as we parse this JSON data is from the request object. Remember we have two objects within our JSON payload, the request object and the context object. So one property within that request object is called type, which is a string. So what we can do is just create a new variable, call it request type, and it looks like I should back up one step actually. If you notice on line 39 here, what I've done is I've implemented a method called try_get_property. Now that's the method that you will use to get the information from each JSON object that comes from the Alexa post request. And you can see here, this is a little bit of C# coding style here. But what we have is our JSON request object, our root element of the object, and then the method try_get_property. The property we are trying to get is type. Remember in, excuse me, I hit the wheel here on the mouse. Remember the property we're trying to get from the request object is called type. So what we do is from the JSON request variable, we try to get the property called type, and out comes a variable called request type. However, since this code runs within this if statement, the variable that we try to set down here, equal to the request type, doesn't think request type exists. So rather than create a new variable at this point, what I do is create the variable before you start the code block or the conditional statement. Create that variable called request type. That type of variable is called JSON element, that's the object. And then over here on the out section, you do not use the var declaration. And now down here, you can set the variable x to the string request type. So I hope you're enjoying. We're starting to get into a little bit more code here. If you haven't seen this new way to parse through JSON, I hope this is helping you figure it out. Before we continue, let's take a little break and take a listen in on Eric. Sounds like Eric's trying to get his next loop going right now, so we'll let him get started on that. There we go. Alright, I just checked. We got 8 more slides, and that includes the last goodbye slide. So we should be done with this fairly soon. Thank you for joining us again. Remember, if you have a question, a comment, or a suggestion for us, please send us some comments through YouTube chat. Alright, we haven't written much code yet here, but we have already gone through our JSON request that is sent from Alexa to your web application. We take that request in through our signature here as an Alexa post request object that we created in our models folder. Once we get that Alexa post request object from the body of the request data, we start parsing that data. We create 2 objects, context and request. Those are JSON document objects. After that, we run a quick conditional statement that says, hey, is our data good? Is the value kind of this object equal to this enumerated value, which is called object? I don't know if enumerated was the correct term there. And after we get our property type, I know Jim's already trying to think of what he can text me so that I can call that JSON value kind dot object value so I can give it its correct name. But after you get that request type, the request type comes back to you from the request object as a string, and you can do whatever you want. After that, once you know what kind of request you're getting, what do we do next? Let's take a look. So you can see my next block of code. What I am doing is I'm creating a variable called request type string, and I'm initializing it to an empty string. What I do is another conditional code block, more data validation. And what I am wondering is if the request type, which is an object, a JSON document object, I'm wondering if that value kind for that object is a string. If it's not, go ahead and throw a JSON exception, invalid request type. Otherwise, set your request type string to the value of the request type, which you can get using the method getString. And I probably should try to get those line numbers in there a little bit better. This way we can read the code a little bit easier. So, once we figure out what our request type is, what we've done is we've parsed the JSON that Alexa sent to us and we got the request type back as a string. We can set the viewData object and the property within the viewData object. We'll just call that property request type. We're going to set that to the value of the request type string. That will allow us to use that information on the UI layer in our HTML. Now, looking ahead to next week's episode, this won't be exactly how we pass data from the C# file to our UI layer. We will actually be passing the entire JSON object to the UI layer. But just for this example, what we're going to do is send merely the string of the request type via the viewData object. And now we're back over to our UI layer. And at the top, we can write some CSHTML. In our code block, we created the variable called get or post. Well, now we have a second variable called request type, and we're going to set that to our viewData object property called request type that we just created in our code behind. And once we set that variable, you can see down here, what I've done is I'm now referencing the value of the request type, and I'm simply taking that string, placing it into the text field of the output speech object of the response object we send back to Alexa, just as a quick example of how this works. And once we publish our web application, we are running on our local host. This is our get view. And when we click on the launch request button in our view, it sends a post request to our web application, and you can see the response here. What we get back is that we sent a launch request to our skill. So once you determine the type of request that the user is trying to send to you, it allows you to respond in different ways. And now back to our testing console after we publish. You can see we processed our skill using the awake word and the invocation phrase. Next, we spoke the utterance of the intent, which we did that by saying the word help. And you can see now, instead of getting the same response each time, we get a different response based on the type of request we send. So we're starting to get a little bit closer towards being able to send a nicely formatted and appropriate response based on the type of request. It looks like we are coming in at just under 40 minutes here. And this is the end of our episode. Next week's episode. Episode 4, we will start building a response. We're going to create another class within our project, which will make sending the response a little bit easier. And what we will end up with, I think it will probably be another 2-part episode, but the goal of the episode is to take the data that Alexa sends us and try to create a localized greeting for the user. So what that means, when we wake our skill, Alexa will respond with a greeting based on what time it is. So Alexa will say either good morning, good afternoon, or good evening based on where your device is located. We'll start going through that process in the next episode. But for now, this one definitely went a lot quicker than last time, so I appreciate everybody coming. It's good to see everybody again. Thanks to the Granite State Code Review Nightly group for hanging out. And of course, thank you so much to my friend Eric Gaudet. My name is Joseph Parzell. Thanks again. This is Code and Coda, streaming live from Boston, Massachusetts every Sunday night. Doors open at 9:15 p.m. We'll see you again next week.
morning.